Okay, so today we're working out of 8.4, and as we go into 8.4, we have to understand sort of our purpose, what's our intention here. And it actually is, we're going to jump into question number 49. I don't want to go through the entirety of the question, but I do want to talk about it a little bit. 49 is the word problem from your text. And there are two equations that it gives to us, or two formulas. It's for a Broadway production. And one is the amount of ticket sales in millions of dollars, and then the attendance in millions of people who come to Broadway. And this is so this is two different equations from 1992 to 2002, so over a 10-year period. The S equation, so the millions sold, can be found by negative 6,420. Plus 292,000, okay, all divided by 6.02 t squared minus 125 t plus 1,000. So this is the equation just for the amount sold. So this is all about money, okay? Think about that. That's the amount of money that they made during that 10-year period for any given year. Now see, the T is for that year. So in 1992, it would be year 0. 1993 would be year 1, and so on. We count our way up. And so depending on what we put in, for T, I think this 640 is supposed to have a, sorry, there you go. That's supposed to have a T right there, and the plus. So if I put in $1 a year, third year, fourth year, till 2002, so during that 10-year period, I put in a year, this is going to tell me how much money I made. And then if we talk about the average, or the number of people who've come, it's negative 407 t plus 7220, all divided by 5.92 t squared. Now this is coming straight out of the book. I'm pulling these numbers from the formula that they were given to us, minus 131 t. Plus 1,000. Oops, missing a 0 there. All right, so that's 1,000 there. All right, but the point that I really want to get at is how would I find out what the average ticket price was? Because if I had the number of people who attended over here, and I have the dollar amount that I made total in ticket sales, how would I figure out what the average ticket cost that year? Now, obviously, I know that I could maybe go back and take all the ticket prices sold and build up what the average would be, but I already have this information in front of me, and I might be using this information to predict future years, and maybe 1993 or one of the years is a specific interest to me because that was the best year for making money, so I want to know what was the cost. Because if you make the cost too high, then the people will stop coming. If you make the price too low, then you don't make any money. And so I'm looking at each of these years and saying, what's the price? Are the prices increasing and I get more money and more people? Or where's the balance? Okay, so if I wanted to find the average cost, I would need to take equation S, okay, the total amount of money, and divide it by equation A, the number of people. Now dividing something like equation S by equation A is not simple and straightforward. And today that's what we're going to do, is we're going to look at some simpler versions. These are pretty messy right here. But we're going to look at some simpler versions of equations where we're dividing an equation by another equation, or perhaps multiplying two equations together, all with the intent of making things simpler or easier to use. These numbers in front of us are a mess. Maybe there's a better way to write them. And that's our focus on today. Okay, so in 8.4, we're very focused on, again, rewriting and simplifying multiplication and division problems with big equations. Fortunately, the problems are pretty easy to work with, and we already have the skill set we need. 2x squared plus 2x minus 4. This is question 11 from your assignment. And we'll start with this question. X squared minus 5x minus 14. All right, so for our steps, the first thing we want to look for is common terms. Okay, so when I say common terms, it's in either the numerator or the denominator, not both. I'm not worried about both at the same time. This is all about factoring to start. Okay, so we're going to factor out common terms first. So if I look at the numerator, okay, is there anything in the numerator that everything divides by, or that everything has in common? It looks like they all have a 2 in common. So I'm going to write it as 2 parentheses, and then I'm going to write out what's left, x squared plus x minus 2. I divided everything by 2. On the bottom, there's nothing in common, so I keep x squared minus 5x minus 14. Okay, so step 1 was to take out common terms. That's this 2 here. Step 2 is factor quadratics. So anything that has a square, x squared, we want to factor those into sets of parentheses. That's our goal there. And so now what I'm going to do is I'm going to keep my 2 there, and I'm going to try using guess and check to factor the top and factor the bottom. It's entirely possible that they don't factor at all, but I have to give it my best shot just to see if it works. So in the top, I'm dealing with an x squared. So I'll go x and x. And then I'm looking at factors of -2. I can use a 1 or I can use a 2. That's it. So I might as well try a 1 and a 2. In order to, now it says they're negative, so one of them's plus and one of them's minus. If I think about this and I want to have a positive 1x when I'm done, I need the bigger number, positive 2, to be positive and the 1 to be negative. Real quick check, that's -1. This is positive 2. -1, positive 2. That adds up to positive 1 right here. Okay, so everything checks out for me. Let's get rid of that. Get rid of that. Okay. I want to go to the denominator now and do this again. I don't want to spend a ton of time rehashing this because I know you know how to do this from earlier in the year. But we're going to go after this. Again, x squared gives me x and x. Okay, the 14, factors of 14 would have a difference of 5. It would be like 2 and 7. So I put my 2 and my 7 in. Now here's the key. Signs are different, and I want a -5 when I'm done. Must mean I need a -7 and a positive 2. Sure enough, this checks out. Well, what was the point of all of that if all I'm going to do is write my answer like this? Well, hopefully, not always, but 90% of the time, there's something that simplifies. And so I want to look at this equation. If you haven't seen it yet, I'm going to write something like this. Okay? What if it was 2xy over y times z? I know this looks different right now, but it really has the same structure. And you notice that there's a y on bottom and a y on top, and they would cancel, and we'd be left with a simpler equation. Down here, there's an x plus 2 and an x plus 2 on top and bottom, so they will cancel, and I'm left with everything else. 2 times x minus 1 over x minus 7. Typically, I get a lot of questions, should I distribute the 2 back into the parentheses? The answer is no. We like to have it factored out, pull it apart, don't put it back together. Okay? And so I guess step 3 would be to cancel. Okay, so you cancel whatever you can. We're going to use those 3 steps for the entire assignment. Questions from the very beginning of the assignment, all you're doing is breaking down what's in front of you and canceling. When we turn the page and we go to questions in the 20s, you're going to have to factor, but you're also multiplying at the same time. And the nice thing about multiplication is that the order doesn't matter. It's really important that we recognize that 2 times 3, okay, times 4 is the same thing as 2 times 3 times 4. I can kind of group all the multiplication together. And so it's important that we realize that once we're doing a multiplication problem, they're all really part of the same thing. They all get to come together. So question number 30 has x squared plus 3x minus 4 over x squared plus 4x plus 4 times, now that times, it's important, but it's not too important, so don't get caught off by it, 2x squared plus 4x over x squared minus 4x plus 3. Okay, and so our first goal is to look for common terms. Always the same. There are no common terms here, no common terms here, no common terms here. This one, they have a 2 in common and an x. The fact that both of them have an x is really important to me. So I really want to make sure that I take everything out that I can. Okay, so the way I'm going to do this is I'm going to go ahead and we'll cross this out and put above it what it's equal to. Okay, so I'm going to pull a 2x out. It's important that you take the variable with it. Otherwise, you're going to have a quadratic left over. So if I take 2x out, I should have x, because 2x times x is 2x squared, plus 2x times 2 would be 4x. Okay? So there's my one piece that has a common term in it. The rest of these are all quadratics, and they need to factor into 2 sets of parentheses. So what I'll do now is I'm just going to go in and I'm going to set up my parentheses. I'm going to leave my times symbol there. The top I already took care of, x plus 2, just like that. Okay, and then 2 sets of parentheses. So I'm setting myself up to do a lot of factoring so that I can look for little pieces that match. So as I start at the top, I'm going to stick an x here and an x here. The 4 is negative, which means I'm going to have different signs, so plus and minus. What are the factors of 4? I have a difference of 3. Hopefully you know that's 1 and 4. And I just need to make sure that I get a positive 3, which means start with a big 4 and just have a subtract 1. Okay. As I come to the bottom, we've got x and an x again. What are the factors of 4 that add up to 4? Well, that would be a 2 and a 2. And notice, because the 4 is positive, the 4 here is positive, that they have to have matching signs. So either both positive or both negative. Well, in order to get a positive 4, they both need to be positive. And some of you might already be noticing, hey look, there's something to cancel. Well, we'll wait till the very end. That's our last step. So we come over here to the right bottom piece, and we've got an x squared, so I'm going to go x and x. And then the 3 is positive, so I'm looking for factors of 3. There's only 1 and 3. 1 and 3. I need them to add to a negative 4. Well, adding means that they need to be the same sign, so they're both positive or both negative. But to get a negative 4, I'm going to have both of them be negative. All right. Now here's where the rubber kind of meets the road, where we have a little bit of a rub, is what do we do with this multiplication sign? But you remember what I said about how when we're doing multiplication, the order doesn't matter? Really what you have is x plus 4 times x minus 1 times 2x times x plus 2. And the order in which you do that multiplication across the top or the multiplication across the bottom does not matter. What that means is right here, instead of having a multiplication symbol in the middle, I'm just going to make this into one really big fraction. Okay? And then I'm going to start canceling what I see anywhere on top compared to anywhere on bottom. It is important that you cancel 1 for 1. So I'm going to start here on the top left. Is there an x plus 4 in the denominator? No. Is there an x minus 1 in the denominator? There's right over there. So I'm going to cancel those. Is there a 2 or an x in the denominator that's without any addition subtraction? This is just a solo multiplier, and I don't see anything like that. Now, is there an x plus 2? Yes, and it's important that you realize you can't cancel both of the denominators x plus 2's. You can only take 1 for 1. So looking at what's left, we're just going to mush everything else together. I like to put the 2x that's a single by itself. So 2x, start there. I've still got an x plus 4. Is that everything across the top? Yes. So then I go to the denominator, x plus 2 and x minus 3. And there's our answer. So we try to pull everything apart into its factored form. We looked for things on top and bottom that matched, and then we canceled those out, and we're left with whatever's left in the problem. Okay? So hopefully, question 30, that kind of made sense. It looks like a lot of work, but really it's just factoring 4 different problems and canceling what factored. Okay? We have 2 more problems we're going to look at. We're going to look at 42 and 43, because they're sort of the complicated ones, but they're even not that much harder than a multiplication problem. They're just division, and that sometimes has a tendency to scare us. So x squared minus 8x plus 15 over x squared plus 4x. We've seen that one before. Divided by, and this is a little bit different, x squared minus x minus 20. All right, so we've got a fraction over here, okay, and we're trying to divide using fractions. Now, if you remember from middle school, or what we've talked about already this year, taking 1/4 and dividing it by 3, that's really hard to do. What's easier is to multiply by the reciprocal. Instead of timesing by 3, let's multiply by 1/3. Okay, flipping times. The same rules that we used in middle school math were setting us up for problems like this. Now, this original problem has a denominator over here on the right of 1. So we're still going to flip in times to make this problem easier. Okay, so I'm going to have x squared minus 8x plus 15 over x squared plus 4x times times 1 over x squared minus x minus 20. All right, so this is going to be a little bit different because now we flipped it, and now we have these two fractions. It's back to multiplication, which means it's going to be one fraction when I'm all done. So I'm keeping that in mind. That was the whole goal here of flipping it, was to make it easier to work with. Now, right here, I notice that these have a common term, an x. I'm going to replace this with x times x plus 4. I want to do that right away, just so I don't forget to do it later. You need to take common terms out at the beginning of the problem, or you'll forget and it'll cause you grief later. So then I'm going to set up my fractions for the top piece. The bottom is x times x plus 4. We're multiplying by 1 over, and then 2 parentheses. All right. As we go through this, we're looking at x squared. That's x and x. The 15 is positive, which means the signs should match. Okay? So that's important to me. They could both be positive or both be negative. 15 has factors of 3 and 5 that add to 8. So I'm going to use 3 and 5. But in order to use 3 and 5, I need them to add up not to 8, but to a negative 8. So I'm going to need a negative negative. Okay? Then when I come down here on the bottom right, I've got x and x again. The 20 is negative, so one of them is positive, one of them is negative. And what are the factors of 20 that have a difference of 1, or specifically negative 1? 4 and 5 are 1 apart. So if I use a negative 5 and a positive 4, that would add up to negative 1. So I'll put a 4 here on the positive, a 5 here on the negative. All I have left to do is look for cancellations. There's no x minus 3. There is an x minus 5, however. So I can cancel those. And you know what? This x plus 4 and x plus 4, they're both in the denominator. I can't cancel them. And this x, they can't cancel with an x minus 3 because see how the x minus 3 is in parentheses? That means that that's one item. It can't be split up. So let's write our final answer. This 1, because there's something in the numerator with it, doesn't really matter. It's not real significant. So we're going to have x minus 3 over x times x plus 4. I have that twice. So you can write it out a second time, or you can write it with a square. Okay? Aside from the fact that we had to flip the fraction upside down, again, we only flipped the right-hand fraction, but we flipped that. Aside from that, the problem was just like the other one before. So let's look at the last question, number 43. And this will be good to go from here, okay? So again, make sure you're getting questions figured out. What do you need to ask about when you come to class to make sure you're confident about getting the process started? So we're going to start with x squared plus 12x plus 32 over 6x plus 42. Now, I'm going to be really sneaky here, okay? In the textbook, it says to divide. But I know I don't want to divide. I want to multiply by the reciprocal. So right now, before I even get very far into the problem, I'm going to change it to multiplication. and I'm going to flip the fraction that's in the text upside down. Instead of writing x squared plus 4x divided by x squared minus 49, I'm going to do x squared minus 49 over x squared plus 4x. Again, I'm trying to be a little predictive. If you don't want to do that, that's fine. You can write it down as a division problem and then change it. Or, like I just did, you can just change it automatically. There's no reason you have to write it down just to change it. You can change it immediately. Now, there are a couple places with common terms. Down here, I see a 6. 6 times x is 6x, and 6 times 7 is 42, so plus 7. Over here, these both have an x, meaning it's x times x plus 4. Okay. Now, I could keep writing down here and rewrite the whole problem, but I've left myself a little space, so I'm actually going to just write everything above the two of them. I'm just trying to save my, if I'm working on my paper, I might leave a little space like that. It stays pretty organized. It's easy to follow kind of what's happening. This is x and x. That took care of my x squared. And I need factors of 32 that add up to 12. And that would be 4 and 8. I put a 4 in one of them and 8 in the other. Because 32 is positive, they're the same. And to get a positive 12, I need plus plus. So that's been factored. Then over here, x squared minus 49 is a special, so I'll cross that out. X squared minus 49 is a perfect square. It's a difference of squares, which makes it special. It's x and x plus and minus 7 and 7. The 7 came because it's the square root of 49. So those are gone. So again, I haven't had to write the problem down a second time. I'm trying to compress my work. If you want to write it out more clean and more thoroughly, you're welcome to. I'm just trying to save a little bit of, I don't know, not effort necessarily, but at times I have to write things down. So I'm looking for an x plus 8, no. X plus 4, there's one there and there. And x plus 7, there's one there and there. X minus 7, no. When I do this cancellation, I like to go from the top left corner all the way to the top right corner. And if I made it all the way across, I should be done. So I see that I have an x plus 8, an x minus 7. Across the bottom, I was left with a 6 and an x, so over 6x. All right, come to class with your questions. Let's beat this out, but it's about factoring. So when we studied factoring in chapter 4, it was really preemptive for this, where we really get into solving significant problems. Okay, so good luck, and we'll see you in class.